Okay, so in this video I'm going to have a look at the Moivres theorem, and I'm going to solve an equation for n equal to q, n being a rational number. So we're going to look at the general form, the general polar form, and we're going to solve this particular equation here. So it's going to be z to the power of 4 plus 2 plus 2 root 3 I equal to 0. So first thing we're going to do is we've got to solve for z here. So we're going to look at z to the power of 4 is equal to minus 2 root 3i. So all I've done is I've taken this bit here and brought it over to this side of the equation. So this is what I've got to solve. Now this is a quartic equation, so there are going to be 4 solutions. The first thing I've got to do is just change this into polar form or general polar form. So let's have a look at it. First thing I'm going to do is just draw it or sketch it. So it's minus 2 root 3i. So it's going to be down here in the third quadrant. It's going to be down here somewhere. So I'm going to have a look at this triangle here. So I'm coming out 2 units and going down 2 root 3 units. The reference angle here is going to be alpha. And we've got to work out what theta is here, this angle here. Okay, so the first thing I'm going to do is work out r. I should have put in r here. R is just the radius here, or the modulus, the distance the complex number is from the origin. So remember, this is minus 2 root 3i, this point here. Okay, so let's work out r first. So r is the square root of minus 2 squared plus minus 2 root 3 squared. So that is the square root of 4 plus 2 2s are 4, 3 4s are 12. So that will give me 16, which is square root of 16, which is 4. So the modulus, or the r, is going to be 4. Now I've got to work out alpha here first, and then I'm going to work out theta. So the way I'm going to work out alpha here is just do tan of alpha is equal to the opposite, which is 2 root 3, over the adjacent, which is 2. So that's just root 3. So the tan of alpha is equal to root 3. So we've got to do tan inverse root 3 to find alpha. So the tan inverse of root 3 is 60 degrees, or pi over 3. So it's going to be pi over 3 here. Okay, so we worked out alpha, this angle here, but really we want to work out theta, this negative angle here. So let's have a look at that. Now, if we take, let's say, from here to here, is going to be pi or minus pi if it's in that direction. So let's say it's pi here, 180 degrees. Now, pi can be written, in terms of this denominator here, can be written as 3 pi over 3. So we want to go back in that direction, 1 pi over 3. Remember, alpha is 1 pi over 3. So we want to subtract 1 pi over 3 from this. So really our theta here, is just minus 2 pi over 3 in this direction here. Okay, so we have our modulus and we have our argument. So let's just write the complex number then in polar form, or indeed in general polar form. Okay, so our complex number was minus 2 root 3i. We're going to write it as 4 cosine minus 2 pi over 3 plus 2n pi plus I sine minus 2 pi over 3 plus 2n pi. This is our general polar form. Now the reason that we are adding 2n pi to our angle is that it accounts for angles that are bigger than 360 degrees. So depending on what n is, we're going around the circle once. If n is equal to 1, if n is equal to 0, we're just looking at minus 2n pi. If n is equal to 1, we're adding another 360 degrees. If n is equal to 2, we're adding another 360 degrees, or 2 pi, and so on. So it just accounts for an infinite number, or an n number of 2 pi's added to our original angle. Now remember that this here was z to the power of 4. If we look back up here, we can see that we've got z to the power of 4 is equal to this complex number here. We've converted that into general polar form, so let's write that out. Okay, so this is our z to the power of 4, so what we've got to do is find z, so we've got to get the 4th root of either side. So really what we're doing is we're getting the 4th root of the left-hand side, or if you like, we're doing this, we're raising it to the power of a quarter. A quarter times 4 is 1, so that's just z to the power of 1. So we do the same to the right-hand side. We raise all of this to the power of a quarter as well. We get the 4th root of the right-hand side. So what does that look like? So we're going to have, let's see, we're going to have 4 cosine minus 2 pi over 3 plus 2n pi plus I sine minus 2 pi over 3 plus 2n pi, and we've got to raise all of that to the power of a quarter. Okay, so what we're going to do next is just use de Moivre's theorem. So we have our z here is going to be equal to 4 to the power of a quarter, which is just going to be 4 to the power of a quarter is root 2. So we have cos. So de Moivre's theorem allows us to take the power and bring it down here, and bring it down here and multiply it by the angle. And we've already done the 4 to the power of a quarter. So let's write that in. So we've got cos of a quarter times minus 2 pi over 3 plus 2n pi plus I sine a quarter times minus 2 pi over 3 plus 2n pi. Okay, so I think that's it. So what we can do now is just multiply out that quarter. So we've got, let's see, square root of 2, we've got cosine of minus 2 pi over 3 times a quarter, so that's going to be minus 2 on the top and 3 fours are 12 on the bottom, so 2 will divide into 12 6 times, so we just end up with minus pi over 6 here. Now when we multiply it by this part here, we've got plus 2n pi over 4. So 2 over 4 is just 1 over 2, so it's just n pi over 2 plus I sine. Again, we should end up with the same thing here. You can do it all out again, but it's just the same thing again. Minus pi over 6 plus n pi over 2. Okay, so what we're going to do now is just use this to solve our equation, to find the roots. So let's start. We're going to start with n is equal to 0. So we're going to start here with n equal to 0. What do we get if we let n equal to 0? Well, if n is equal to 0 here, that just means this will disappear and this will disappear. So really all we've got to do is find, let's call it z1. It's going to be square root of 2 times the cos of minus pi over 6 plus I sine minus pi over 6. Now if you take minus pi over 6, let's see where that is. We just kind of quickly sketch that again. We've got minus pi over 6. That's going to be down here somewhere, let's say. It's 30 degrees in the negative direction. So we're looking at this angle here. So if we want to find the cos and the sine of that angle, we've got to look at our reference angle here. So what we have is our reference angle here, which is pi over 6. If we find the cos and the sine of pi over 6, we have our root 2 anyway. We have our root 2. The cos of pi over 6, is root 3 over 2. Root 3 over 2. Now remember, we have A, S, T, C. So all sine, cos, and tan are positive here. Sine is positive here, tan is positive here, cos is positive here. So this is going to be positive root 3 over 2 here. Now sine of pi over 6 then, sine of pi over 6 is a half. So the sine of minus pi over 6 is going to be a half. However, sine is negative in the fourth quadrant, so it's going to be minus 1 over 2 I. So if we multiply this out, our z1 then is just going to be root 2 times root 3, which is root 6 over 2, minus root 2 over 2 I. So this is our first root. So that's our first root. Okay, so let's look at the next one then. Next thing we've got to do is look at n is equal to 1. So what do we get if n is equal to 1? So if n is equal to 1, that means, if we go back up here again, remember we're looking at this here, n is equal to 1 here, and n will be equal to 1 here. So we've got to add these two together. So it's minus pi over 6 plus 1 pi over 2. So we have minus pi over 6 plus pi over 2. So you can do that on your calculator, minus 1/6 plus a half. That will give you 1/3, so it's just pi over 3. So this will just end up as 1 over 3, and including the pi there is just pi over 3, pi over 3. Okay, so that's going to be our angle. Let's write that out. So we have Z2 then is going to be equal to root 2 times cos pi over 3 plus I sine pi over 3. You can work that out. Root 2 is the cosine of pi over 3. The cosine of pi over 3 is a half. And the sine of pi over 3 is root 3 over 2 I. That's it. That's our solution. So that's just going to be root 2 over 2 plus root 6 over 2 I. This is our second root, our second solution. Okay, let's go again then. We're going to look at n is equal to 2. So n is equal to 2. Remember there are 4 solutions, so we've got to only go as far as n is equal to 3. n is equal to 0, n is equal to 1, n is equal to 2, and n is equal to 3. So we have n is equal to 2 now. So let's go back up again, look at where we put in that 2. So we want to put in the 2 here and here. So what do we have? We have minus pi over 6 plus 2. Remember we're putting in 2 now, so it's going to be 2 pi over 2, so that's just going to be pi. So got to add pi. Now, if you think about pi, another way of writing pi is 6 pi over 6. So we want to take 6 pi over 6 and subtract 1 pi over 6, so that's just going to be equal to 5 pi over 6. So this is going to be our angle, 5 pi over 6. But let's stick that into our equation. So this is Z3. So Z3 is going to be square root of 2 times the cosine of 5 pi over 6 plus I sine 5 pi over 6. Now if you look at 5 pi over 6, 5 pi over 6 is almost 6 pi over 6, which is pi. So again, this is the real, this is the imaginary. So 6 pi over 6 is pi. That's going to be 180 degrees, or just pi. So we want 5 pi over 6. 5 pi over 6 is going to be about here. So this is 5 pi over 6. So that would just mean our reference angle here is going to be 1 pi over 6. That's our alpha there. So let's work out our cos and sine. So Z3 is going to be equal to the square root of 2 times the cosine of 5 pi over 6, which is the same as the cosine of our reference angle, which is pi over 6. So the cosine of pi over 6 is root 3 over 2. It's in the second quadrant. Remember, we're in the second quadrant, so they're all positive here. Sine is positive here. Tan is positive here. And cos is positive here. So the cosine is going to be negative in the second quadrant. So it's not root 3 over 2, it's minus root 3 over 2. Minus root 3 over 2. So now we've got to work out sine. Well, sine is positive in the second quadrant, so that's okay. All we've got to do is find the sine of pi over 6, which is the same as the sine of 5 pi over 6. So the sine of pi over 6 is a half, so it's just going to be plus a half I. If we just multiply that out, we get our third root here, so it's going to be root 6 minus root 6 over 2, minus root 6 over 2, plus root 2 over 2I. So this is our third solution. Okay, so just one more to do then. We're just going to do n is equal to 3. So let's do that. So we have n is equal to 3. So what happens if n is equal to 3? Let's just go back up here again. Okay, so what we want to do now is just put 3 in here. So we want to put 3 in here and 3 in here. So that will give us, let's just do that again. So we have minus pi over 6 plus 3 pi over 2. 3 pi over 2. So let's do that. How can we do that? Let's see. We have a pi over 6 here, minus pi over 6 here. Let's make this 6, so that would mean multiplying by 3. So you've got to multiply the top by 3 as well, so that would be 9 pi over 6. So now we've got plus 9 pi over 6 minus 1 pi over 6. That gives us 8 pi over 6, or just 4 pi over 3. 4 pi over 3. So that's going to be the angle we're going to put into our equation. 4 pi over 3. So let's do that. Okay, so we have Z4 now is going to be equal to square root of 2 times cosine 4 pi over 3 plus I sine 4 pi over 3. So let's work this out. Now we want 4 pi over 3 this time. Let's see where that is. So 4 pi over 3 is just one more than 3 pi over 3. So this is 3 pi over 3 here. This is pi out to here, which is 3 pi over 3. It's the same thing. So we want to go just one more than that. We want to go 4 pi over 3. So we're in the third quadrant down here. So this is 4 pi over 3. Now our reference angle here is just going to be pi over 3. Remember, we have 3 pi out over 3. We have 3 pi over 3 out to here, and then we want another one. 4 pi over 3 will bring us down as far as here. So we want to find the cos and the sine of our reference angle, and then work out whether it's positive or negative. ASTC. Okay, so let's do that. So Z4 is equal to square root of 2 times the cos of pi over 3. The cos of pi over 3 is equal to a half. It's the same as the cos of 4 pi over 3. However, cos is negative in the third quadrant, so it's going to be minus a half here. Now let's do sine. So sine of 4 pi over 3 is going to be the same as sine of pi over 3. So sine of pi over 3 is root 3 over 2. So that's going to be root 3 over 2i. Now in terms of the sine, let's see, it's in the third quadrant. Tan is positive in the third quadrant, so sine is negative in the third quadrant. So it's minus. Okay, now we have Z4 then is equal to minus root 2 over 2 minus root 6 over 2i. And that's our fourth solution. Okay, so let's have a look at those 4 solutions. We had Z1 is equal to root 6 over 2 minus root 2 over 2i. We had Z2 is equal to root 2 over 2 plus root 6 over 2i. We had Z3. Z3 was equal to minus root 6 over 2 plus root 2 over 2i. And Z4 then finally was equal to minus root 2 over 2 minus root 6 over 2i. So these are our 4 solutions. We can actually plot those on our complex plane again, and you should find, again, if this is real, this is imaginary, you should find that they are 90 degrees from each other. So let's have a look at the first one. Root 6 over 2 minus root 2 over 2i. That's going to be somewhere down around here. So that's our first one. This would be Z1 here. The second one, Z2, is going to be in the first quadrant, so that's going to be 90 degrees from that, so it's going to be up around here. Again, the same distance from the origin, so this is our Z2. Our Z3 then is going to be out here somewhere. This is our Z3. and Z4 then is going to be down here somewhere. This is going to be our Z4. I'm not sure if I have those distances exactly right, but that's generally the way it works. This will be 90 degrees here because there are 4 solutions. If there are 3 solutions, there would be 120 degrees between them, and if there were only 2 solutions, there would be 180 degrees between them. Okay, so that's really it for this video.